So for the ungrouped data, I don't think you had any pie charts homework. You just had this question to finish, right? So we will look at the line graphs question. Now, if you want to communicate, you either unmute yourself and talk, or you could message me on WhatsApp if you don't want other people to see it. If you're chatting on Zoom, chat to everyone, not to me directly. If you chat to everyone, I'll be able to see it. Okay, so the line graphs question, I have my line graph already drawn. You were supposed to do this for homework, so you should have a line graph that looks something like this. Of course, it would be on actual graph paper. So we're looking at the questions, right? So from parts B, C, and D, that's what we're looking at here. So it says, on your graph, show how to estimate the population of the country in 1998. Write your estimated value. Okay, so you just find 1998 on the x-axis. Go up to touch, use a dotted line. I use a solid line, but you should use a dotted line, right? Use your ruler, of course. Go up to touch the line graph and then go across. You might not get exactly what I have, but it will be something close. So the answer, when you go up and across, is 1.8 million. Right, that's the population in 1998. This is 1998 there. During which 5-year period was there the greatest increase and the smallest increase? Okay, so the greatest increase would be from, you're seeing the greatest increase here. This is where the graph is the steepest, right? So the greatest increase there is 1990 to 1995. And then the smallest increase is this region here, right? So that's 1995 to 2000. Okay, give me a second. Okay. Right, so we have the greatest increase and the smallest increase, right? So the greatest increase is here, 1990 to 1995, and then the smallest increase is there, 1995 to 2000. And now we want to explain how the two facts are shown on the graph. How it's shown on the graph is with the gradient, right? So the greatest increase would be the steepest gradient, and then the smallest increase would be the most gentle gradient. Steepest, or you could say highest gradient. And the smallest increase will be the lowest gradient, or the smallest gradient, right? Great, and that's how we show the two facts on the graph, right? Now it's 1 mark, so if you just said with the gradients of the graph, most likely you would have gotten the mark, but we want to just be certain. Okay, so, all right, so now we are moving on to grouped data. All right, so grouped data, when we are looking at grouped data, we have some important definitions, right? Some very important definitions looking at grouped data. So when we have grouped data and like this, right? You have different classes of data. Now, why you would have to group data in the first place is if, let's say, you have values from 1 to 100, it doesn't make any sense having like a bar graph and then 100 different bars on the bar graph, right? That would be a little too complicated. So you could just group it. So you group from 1 to 10, 11 to 20, etc. So instead of having 100 bars, if you do the grouping, you could have 10 bars. That's a little bit more manageable, right? So whenever you have a large number of values, it's easier to collect them into classes, right? So we are looking at the vocabulary around grouped data. So this will be in the PDF. If you want, you could start writing them down, right? You might not have enough time to write every single thing down, but you could always go back to the PDF afterwards and copy it out, right? So the definitions are important, and how the questions come, right? It's not like the question wouldn't say define a class boundary. I've never seen a question like that. But what they could do is give you a class and say, well, what is the upper class boundary of this class for 1 mark or something like that, right? So you need to know what each definition means, and they're very easy to confuse between one another, right? Okay, so let's start. Class intervals. Each grouping is a class interval. And then the numbers that you see, if you have the class intervals like this, are class limits. Now, sometimes, especially in newer years, you might see the intervals looking a little bit different. So if you see an interval looking something like this, x lies between 0 and 10, and then x lies between 10 and 20. Something like that, right? If you see the intervals being written like this, it's different, and those numbers represent the boundaries, right? And how you would know the difference is if you see overlapping numbers. If you see overlapping numbers, then the numbers are boundaries. But most of the time, if you just see it like this, and then the numbers don't overlap, so like there's 10 and then there's 11, no overlap, those are the limits. Okay, so if you see data like this, the numbers that you see are the class limits. The class boundaries, now this is the one that is a little bit tricky. Let's look at the definition for class boundaries. Class boundaries are the midpoint between the upper class limit of a class and the lower class limit of the next class in the sequence. Therefore, each class has an upper and lower class boundary. Well, what does that what does that even mean? You might ask yourself. Give me a second, right? Let me just check the waiting room. Okay, so class boundaries, this is the part that is definitely the trickiest, but if you just pay attention, it's not going to be that bad, right? So I'm going to write out the groupings, or at least some of the groupings. So let me write it out. So the groupings are 1 to 10, 11 to 20. Let me write it. 1 to 10, 11 to 20, 21 to 30. Now there are 2 more, 31 to 40. And then we have 41 to 50. Okay, those are the groupings, right? I have it in our table here. So we want to figure out what the class boundaries are. So where are the boundaries? The boundaries would be in the middle of each limit. So this here is a boundary, here would be a boundary, here would be a boundary, here would be a boundary. So how do we find the boundaries? Okay, the upper class limit of one class. So the upper class limit of the first class is 10. And then the lower class limit of the next class is the 11. So if we just take the average of 10 and 11, we will get 10.5. You see? So the boundary is 10.5. It's the average of 10 and 11. That's all it is, right? That's the boundary. Same way here. if we're looking at the average of 20 and 21, that is 20.5. Or the average of 30 and 31, you get the idea? It's 30.5. So those are the boundaries. Now, you would similarly follow that trend. And if you wanted, you would get 0.5 because you see a trend in the boundaries, right? And then this would be 40.5. And then 50.5 would be the next boundary there. Now, what you would notice is that the boundaries are shared. It's like two houses or two plots of land and they share a fence. Okay, so if you have my fence to the right of my house is going to be my neighbor's fence to the left of their house. So what that means is, for this class, the upper class boundary is going to be 10.5. But for this class, the lower class boundary is going to be 10.5. It's a shared boundary, but it's the upper class boundary of one class and the lower class boundary of the other class. You see? Let's start filling this in. We'll come back to these two afterwards, right? So we have this table. This is in the PDF. So you could try, if you didn't print it out, you could copy it down. You don't have to be too neat about it. This is not a past paper style question. Okay, this question is simply to get you to understand the vocabulary a little bit. All right, so we have each class here, right? So we have 5 classes, and let's just practice writing in the class limits and the class boundaries. So as I said before, if you see classes written in this manner, the numbers that you see are the class limits. Okay, so the lower number is the lower class limit. The higher number is the upper class limit. Right? That's easy. And then the boundaries, let me bring that down a little bit. Okay, so I was showing you some working for the boundaries. Okay. So let's look at the boundaries. So I did the working for the boundaries already in red. So if we look at this first class, okay? So let's look at the first class. This class here. The lower class boundary is 0.5. The upper class boundary is 10.5. Now, if we look at the next class, here. For that class, the lower, because the boundaries overlap. Okay, the limits don't overlap, but the boundaries do overlap. So the lower class boundary of the second class is 10.5. And then the upper class boundary of the second class is 20.5. And then once you start to see a trend, you could just fill in the trend. It's not going to be too difficult once you see the trend. Right? Now, let me know if you follow that there. Just type a Y in the chat if you follow that. If you're not sure, just let me know and I could go through it again. Okay. Okay, great. So we looked at class limits and then we looked at class boundaries. And now we want to look at class width. Class width is very easy. Now, so the class width is the upper class boundary minus the lower class boundary. So it is not the difference in the class limits. it is very important. It's the difference in the class boundaries, right? So if I were to just get it mixed up and say, okay, 10 minus 1 is 9, that would be incorrect, okay? Because I'm not looking at the class limits. So what are the boundaries here? 10.5 and 0.5. So 10.5 minus 0.5 is 10. And then for this one, 20.5 minus 10.5 is 10, etc. Now the class width is constant. Is it possible to have a set of grouped data and they vary the class width? Yes, it is possible. I have never seen it in a CXC past paper. I've seen it in textbooks, but not in CXC. Now, that doesn't mean there's a very small chance that they might try something new. Yeah, I don't know. But most likely you will have a constant class width, right? It doesn't have to be 10, it could be 10.5, something like that. And then the class midpoint. All right, class midpoint. Now, the good thing about class midpoint is you could use two formulae. So you don't have to worry about, do I have to use boundaries or do I have to use limits? It doesn't matter. So you either use the upper class boundary and the lower class boundary of the same class, or the upper class limit and the lower class limit of the same class. I like to use limits because it's whole numbers, but it doesn't matter. You could use the boundaries as well. You'll get the answer. So the class midpoint is the average of the class limits. So we have, what is the average of, let's see, what are our two limits here? The lower class limit and then the upper class limit. We have 1 and 10. So the average of 1 and 10 is 1 plus 10 over 2, which is 11 over 2. 11 over 2 is 5.5, right? So that would be the average of the 1 and the 10, right? That's how I get that. Now, if you wanted to take the average of the 0.5 and the 10.5, it's the same 11 over 2, right? You get the same thing. And now let's look at the next class. The lower class limit and the upper class limit. 11 and 20, right? So we have 11 plus 20 over 2 is 31 over 2. So 31 over 2 is 15.5. And then if you wanted to take the average of these two numbers, you would still get 31 over 2, which is 15.5, right? So that doesn't matter. All right. And then you get the idea, right? So we take, for the next one, we will take the average of 21 and 30, right? So that'll be 51 over 2, which is 25.5. Now, what you're going to notice is that there is a clear trend. So once you see that trend, as long as the class width is constant, in this case, you just keep adding 10, right? So I don't need to actually calculate it every time. I could just add 10 every time, and I have my class midpoint, right? So as soon as you could see a trend with a constant class width, you could just follow the trend. All right, so I'm going to give you a couple minutes to copy that table down if you didn't start already, and then I'm going to move on. So again, this is not a past paper type question. Question 2, we are going to look at a past paper question. This is just to get you accustomed to the vocabulary. Right, so a couple minutes and then we'll continue. All right, so let's move on now. Okay, so this is past paper question. We have some group data, and then we have some questions based on it. So we want to find, first we want to find the modal class interval. So modal class, what you would realize is the word modal sounds like the word mode. And then mode, when you just have a list of numbers, the mode is the most common number. So if we are looking at the modal class, it's the most common class. So that's the class with the highest frequency. So the highest frequency that we could see is 25. So therefore, the class with the highest frequency is this class, 20 to 29. That's it. All right, so you just look for the most common class. That's a very easy 1 mark. Right, modal class. Next, state the class interval in which a score of 19.4 would lie. 19.4. All right, now there are two classes that you might be looking at. There's the 10 to 19, and there is the 20 to 29. Now, where does the 19.4 lie? Well, remember that the boundary between 19 and 20 is the average of 19 and 20, which is 19.5. So if the boundary is 19.5, 19.4 would still fall in the 10 to 19 class. 19.6 would be in the 20 to 29 class. So we have the answer would be 10 to 19. Copy and complete the table to show the class midpoints and the values of f times x. Now, we did look at finding the mean for a frequency table, not for grouped data, but it's very similar. All right, very similar. So all we have to do first is find the class midpoint, right? So instead of just one raw score, we are using x as the midpoint. And once you do that, it's going to be very similar to what we did before. Now, there are two ways to do it. Of course, you could just find the average of the 20 and the 29 and the average of the 30 and the 39, etc. But in this case, they already started you up so helpfully by giving you the first two class midpoints. So since the class width is not changing, you could simply follow that trend and keep adding keep adding 10 every time. Okay, so if you want to do it like that, keep adding 10. You get the same numbers, right? But it's the same as if you took the average of the class limits. Right. Now it says total here, but the total for the column X doesn't mean anything. Okay, so the only total we need to concern ourselves with is for the frequency column and the FX column, right? I would suggest that you just put a big X here, because if you try to add it up, you're gonna get a number that doesn't mean anything, and then if you try to use that number somewhere, you will just get the wrong answer. So just ignore this block there. Okay, so I'm gonna give you I'll give you some time to try it. Okay, so to fill it in, to get this, it'll take a little while, but just take your time with your calculator, right? You get the product of this number and this number. So you take this times this to give you this number. And then you will fill out 1, 2, 3, 4. And then when you do that, you add up all these numbers, right? So the sum of all those numbers you put in there. Okay, so that will be part B. Okay, and then when it's time to find the mean, okay, the mean for part B, part 2, the mean is the sum of fx over the sum of f. So all that is whatever number you get here, that is the sum of fx. And then the sum of f is 100. You get it? So I'll give you some time to copy that down and complete the table. Go ahead. Okay, so I'm gonna start filling in the table. Actually, I'll leave the shading on this. Okay, so you should have gotten that the average score was 31.4. Right now, if you didn't get that, just look at the table again and see where you went wrong. It's possible that when you were if you were adding up, you may have added just these 4, but remember you have to add up all 6 fx values to get the total, right? So it's the total of all of them. If you are not sure what you did wrong, you could always send me a picture of your working and I could check it. All right, so you would realize that this was a good bit of marks. So to fill in the frequency table and the calculate mean was five whole marks. That was a good bit. Compared to only 1 mark for the modal class interval. But that wasn't really any kind of calculations. All right, so we're moving on. Part C. Explain why the value of the mean in B part 2 is only an estimate, interesting, of the true value. So this mean is not necessarily the actual average of the class, right? So like if I took the raw values, right, and not just the values from the frequency table, if I took the raw values, like the list of all 100 scores, added them up individually instead of using the grouped data, if I add them up individually and then divided by 100, I would have gotten something close to the 31.4, but not necessarily the same thing. Now, why is that? Anyone care to guess why they think that might possibly be before I give you the answer? All right, well, let's look at the 0 to 9 score. I'm going to give you an example. So according to this, there are 8 people who got a score between 0 to 9, right? Now, what if these were their scores? The people who got between 0 and 9. Let's say out of the 8 people who got between 0 and 9, 4 of them, they just completely gave up and they got a flat 0. And then we had 2 people who got 1s, and then 2 people who got 2s. Now, the average for these 8 scores is clearly much lower than 4.5, right? But it doesn't matter. In order to get the class midpoint, you're just taking the 2 limits, right? So we're taking the 2 limits or the 2 boundaries, whichever. And that is what we have to use to get the class midpoint. So that value of 4.5 is representing the class. But in actuality, the class score is lower than 4.5. And then if you imagine that something similar to that might happen for every single class, the values that we calculate are going to be slightly off, right? Maybe a lot off. So why we say it's only an estimate of the true value for part C, we would say that x is the midpoint, right? You know what, let me say the class midpoint x, right, is only assumed to be the average value. It's not actually, right? It's only assumed to be the average value of each class. See? That's why. And then the last part D. So probability, we did that before. So if you recall, probability is the total total favorable outcomes over the total number of outcomes. Now, we were already told that there were 100 students in the competition, right? So we know that the total outcomes is 100. Now, favorable outcomes is whatever the question was asking for. So what was the question asking for? The people who scored at least 40 points. Now, at least 40, that means 40 and over, okay? So whoever scored at least 40 points, that would be these people, 40 to 49, 50 to 59. So that would be the 20 plus the 12, right? So that's the number of favorable outcomes, right? So 20 plus 12, that will give me 32 over 100, and that will just be 0.32, right? Okay, so I'll give you a second to copy down the answers for C and D, and then we'll move on to histograms. Okay, so let's move on now. All right, so number 3, you could do this one. Okay, now let's look at this one. This one is an example where they stated the values using boundaries, okay? So instead of giving you the limits, they gave you the boundaries. Now, it doesn't quite matter because they gave you the midpoint anyway. So it doesn't really affect your working, but I'm just mentioning that if they give you the values like this and you're seeing overlap there, these numbers are not limits, they are boundaries, right? But whichever, they give you the midpoints anyway, so you don't have to worry about anything else. And then we did look at finding median as well, so you could try that one for homework. Let me write that down, right? So write it down. All right, so question 3, this is the June 2021. That is to do for homework. Okay. So now we are moving on to histograms. A histogram is very similar to a bar, right? The difference is a histogram is used for continuous data, right? So usually grouped data. Now, whereas in a bar graph, you could draw the bars touching one another or not. It's you could so you tend to like to leave spaces between the bars on a bar graph, but not every single time. In a histogram, you never draw the rectangles so like this, never, right? You would never see a histogram like this. In a histogram, the bars always flow together. Why is that? Because a histogram always displays continuous data. So there isn't really a gap. So if you're looking at masses, it's continuous. Heights, time, it's always continuous. So to demonstrate continuous, the bars flow together. Okay, now, in my experience, out of all the types of graphs, because there are a lot of graphs, right? The bar graph, line graph, pie chart, histogram, what we're doing now, then we still have to do frequency polygon and cumulative frequency curve. Okay, so we have a lot of different types of graphs. Out of all of them, students tend to make the most mistakes with the histogram. And why? Because they always get the boundaries wrong. Okay, so we watch out for that. Watch out for where you're drawing the boundaries. Okay, so be careful when you are drawing the boundaries. So the boundaries, what you're drawing on the boundaries are going to be the vertical lines. All right, so whenever you're drawing your rectangles, those vertical lines are going to be on the boundaries. So let's look at an example, right? So we are going to look at an example of, well, you're going to draw this for yourself, right? So you need to get graph paper. So what you should do, you could just copy this down quickly. So you will have this for reference, right? Now, most of you don't have the hard copy. If you do have the hard copy, you could just use the outline that was given here, right? If you printed it out, you could use the outline. If you don't, you could use graph paper. It'll be a little bit harder to use graph paper. It'll be a little bit harder to see it, but that's okay. Because I have the same diagram done on graph paper. I'm gonna talk you through it. Okay? So we're gonna do it step by step. Now, if you don't have graph paper, it's gonna be a little difficult. You could still pay attention, but you need graph paper to practice this. It's not enough to just look at it and say you understand. You need to actually draw it for yourself. Okay? So I'm gonna scroll. I think since most people will be using graph paper, now again, if you have the handout, yeah, you know what? If you have the handout, take a screenshot quickly, right? And then you will, this is what you're gonna refer to for the handouts. When I'm gonna scroll, and then what I'm doing when you scroll is what you're gonna use if you have to use graph paper, right? Okay, so you should have had enough time to take a screenshot of this if you're using the handout. All right, so this is what it will look like. It's the same thing, just a little taller. Okay, right. So I'm gonna let you do it in steps. What's the first step? Step one, draw up your axes. Okay? What are the axes? The axes would be, this is the y, well, the y-axis is the frequency axis, and then the x-axis is the masses. Okay? So start with your axes. Don't worry about anything else. I would suggest that you follow the scale that I have. So in this scale, this is a 1 centimeter block. Okay? In some of the graph paper that you have, you don't really see the 1 centimeter clearly. You see a 2 centimeter grid clearly. Okay, but this grid is a 1 centimeter block. If you're not sure, measure it so you'll know what a 1 centimeter block is. So start with your axes. Okay, start with your axes and then draw them up exactly how you're seeing it here. Okay, I'm gonna give you a couple minutes to start with the axes, and then we'll talk about the next step. Okay, so 2 minutes to draw up the axes and label the axes. Okay, go ahead. If you would like me to check your axes, just send me a picture on WhatsApp. Right, so again, everybody should be doing the 2 axes, right? That's what we're doing now. All right. So by now, hopefully everyone should be finished their axes, or at least nearly finished with their axes. The next step would be to find, well, and mark off the boundaries. Okay. Now, of course, you're not writing this down, but I'm writing it down, right? So the first we do axes, Then for a histogram, you want to get boundaries, right? And mark them off. So let me show you how to calculate the boundaries, okay? Well, I did it before, but I'm doing it again. So these are the classes, 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25. So where are the boundaries? Average of 5 and 6 is 5.5, you see? The average of 10 and 11, 10.5. The average of 15 and 16, 15.5. Average of 20 and 21, 20.5. Now, for the endpoints, you could either imagine a class that came right before and right after and do the calculations, or you could just follow the trend in the numbers. So here you would have 25.5, and then here you would have 0.5. So these are the boundaries, okay? 0.5, 5.5, 10.5, 15.5, 20.5, 25.5. So these are the boundaries. We want to mark off those boundaries before we draw in anything, okay? Because it's very easy to get those wrong. And I've seen this thing year after year, people get them wrong all the time, okay? So take my advice, mark off your boundaries first, just do it in pencil. So if you have this, it's going to be easy. If you have the printout, it's going to be easy to find it, okay? So where's 0.5? Well, it's halfway between 0 and 1. So 0.5 is here, 5.5 is here, 10.5 is here, etc. So you're not drawing the rectangles yet. You're just in pencil. Or if you want to do it with a colored pen, because it's the first time, you don't usually do it with color, but for the first one, if you want to do it in color, that's okay. You mark it off, right? So let me show you on the graph paper. It'll be a little bit harder on graph paper, okay? So on graph paper, it's harder to see. So you count it off. So if you know this is 0 here and 5 here, a lot of people get mixed up and they think that this is it. 0. This is not 0.5. Okay, I've seen people do that. Okay, that's not it. Where's 0.5? You count. So if this is 0 and this is 5, then this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, so if this is 1, then a half is going to be half of that. So in this case, 0.5 is one small block. This is based on the scale that I used, okay? It's not always going to be one small block. Depending on the scale that was used, sometimes it's going to be half a block, maybe even quarter of a block. So you always read your scale carefully. But based on this scale, 0.5 is going to be one small block. So what that means is 0.5 is here, 5.5 is here, 10.5, 15.5, 20.5, 25.5. So mark that off now, right, in pencil, and it will make it easier to draw your bars. Okay, I'm giving you, if you have your axes already, it shouldn't be too difficult, right? So I'm giving you maybe a minute to just put in the lines at where the boundaries are. So now, once you have marked off the class boundaries, it's going to be easy, right? So you have your axes, you have the boundaries, and now all you need to do is fill in the rectangles, okay? So the heights of the rectangles are going to correspond to the frequencies, okay? The vertical lines, which tells you where you're going to draw the sides of the rectangles are the boundaries, and then the heights of the rectangles are the frequencies. Now you could see I have the graph there, right? So the last step is to draw in your rectangles, okay? The height, so I have the table at the side there, so you could just refer to the table and go ahead. So draw in your rectangles now. Okay, so next you draw in the rectangles, and then lastly, you just fill in all the labels, okay? So whatever the data is, I have mass, quantity, and unit. Don't write upper class limit. That's not what you're gonna write. You just write mass, right? So draw in your rectangles, then put in all the labels. You could just follow what I have for the label. What I have as the label on the y-axis is frequency. You could write the word frequency, or if you prefer to write number of plant samples, you could write that as well. And then, of course, put in a title. Okay, so I'll give you a few minutes to finish up the histogram. When you are finished, please send me a picture via WhatsApp so that I could check your work. Okay, so you should be finished by now. If not, you could always finish it up for homework, right? So I'll give you another one for homework, right? There are actually several in the PDF, but I'll give you one for homework. You could do as many as you want, right? But this one is for homework. I think I will also send you the answer so you could refer to what you don't have to color it. I only colored it so it will be easier to see. Okay, so the PDF has a few more. You could do as many as you want, but the rest are optional. At least do number 2. Okay, just to get some more practice. Okay, so the rest of them, I could probably just send you the PDF, this PDF with the answers. This is not the PDF you already have. You don't have these answers. Again, I only colored it to make it easy to see. You do not have to color yours. All right. So I might just send you the PDF. I might just send you the PDF so you could see the histograms. Okay, so now we are moving on to frequency polygons, right? So we did histograms. A histogram is a type of frequency distribution, right? What is a frequency distribution? Well, it has frequency on the y-axis and whatever the data is on the x-axis. So it's a frequency distribution. A frequency polygon is also a frequency distribution because it has the frequency on the y-axis and then the data on the x-axis. Now, frequency polygons and histograms are actually related. So let me just go to a histogram. Now, if I were to take a histogram and then just take the midpoint of each class, right? And then join it. Not as scrappy as this, of course. If I were to join it, and of course I would have to go join to the x-axis back, right? So just using the tops of the bars, the middle of each top of the bar, and join them together, that is a frequency polygon. Okay, so there's a relationship between the histogram and the frequency polygon. But usually they don't do 2 on one diagram. It's either or usually. So in a frequency polygon, it's not difficult, but it's easy to just confuse what you have to plot for each one, you know, to get them mixed up. So for the histogram, remember you use the class boundaries to get your vertical lines. For the frequency polygon, you use the class midpoints. And with this one, you are plotting coordinates, plotting points, right? So the points that you need to plot would be x coordinate is the class midpoint, and then the y coordinate is the frequency, right? That's how you get a frequency polygon. And a complete frequency polygon is going to start and end on the x-axis, right? Now, is it possible to find something and they call it a frequency polygon and they just do this part? Yes, it is possible, but the best practice is to always connect it back to the x-axis. Okay, why is that? Because if you know what a polygon is, you could go in the dictionary or go on Google and look up the word polygon. A polygon is a closed shape with straight sides. So if I were just to draw a line is not a polygon. Connecting it to the x-axis makes it a polygon. It's closed now when I connect it to the x-axis. And how do I connect it to the x-axis? I just follow the trend in the class midpoint. So if I was plotting like 54.4, 64.4, etc., I just follow the trend in the midpoints and that tells me how to connect it back to the x-axis. If you're a little bit confused, don't worry. When we actually practice the question, it will get hopefully a little bit clearer. Okay, So here's the thing. I had this already done. Okay. So now, in the interest of time, I think I'll just use this. Now, those of you who don't have the printout, you'll have to use graph paper, but that's okay, right? You'll still be able to do it. Now, the first thing that they wanted was to find the mean. Let's omit, well, you could do this for homework, right? We already did finding the mean for a frequency table. Okay, so the answer, I'll just give you the answer. The answer is 17.85 kilograms. And then you could just follow the working like what we did earlier and try to find the mean. But I'm gonna focus on the frequency polygon. Okay, so draw up your axes. I'll give you maybe 5 minutes to draw up your axes. You could use it based on this, right? So draw your axes up and then we'll go through how to find the frequency polygon, to draw in the frequency polygon. Right, so use this as a guide. Go ahead with your axes. I'll give you maybe about 5 minutes and then we will look at the polygon. But it's easy. It's the x coordinate is the midpoint. And then the y coordinate is the frequency. And then you just, if you're looking at the x coordinates, you just follow. In this case, you could just keep adding 5. Or just take the average of these two values, and then you'll get the class midpoint. So they're calling it mid-interval value. That is the same thing as the class midpoint. All right? So go ahead. If anyone is not sure what they have to do, just send a message or unmute yourself or whatever. I think most people should know what they have to do, right? So axes, and if you drop the axes, you could start plotting. Okay, so by now, you should have your axes drawn up. So it's just to plot, okay? So remember, you have your x coordinates and your y coordinates. I'm going to write out the points to plot. You don't necessarily need to write it out, but I'll write it out for your sake. So the class midpoint as the x coordinate, and then the frequency as the y coordinate. So 7 to 1229, 1737, 2216, 2714, 32, 2. Okay. And now what you notice is that they started at the x-axis. So we are going to also finish at the x-axis. So we're going to follow the trend. Okay, so the next value would have been 37. And then that to get it on the x-axis, we're going down to 0. Okay, so the last point will be 37, 0. So let me just plot those points there. It might not look exactly, it will look more or less like this, but the scale might be a little bit different if you did the graph paper. But it will look pretty much like this. Right, so I'll give you a chance to finish up the polygon. Remember to put in your labels as well. If you, whenever you finish with your polygon, you could send me a picture via WhatsApp, so I'll just be able to check your work. And labels are the title of our graph is very important, right? You might be able to get away with not losing marks in a test, but it's still good practice. And then you could lose marks in a test for not having a label. More for term tests than CXC, but still. All right. So I think most people, if you didn't finish, you could always finish it for homework. Let's look at part C. Calculate the probability that a cow chosen at random from the experimental group gained 20 kilograms or more. So I'm just going to erase this so I'll have a space to put the answer for part C. Okay, so we know that the probability is the number of favorable outcomes. You don't have to state the formula if you don't want to, over the total number of outcomes. You can just go straight to the substitution. So the total number of outcomes, it's not always going to be 100. It's just whatever the question has, but it's 100 cows. So the total outcomes is 100. Favorable outcomes is whatever the question is asking for. So that would be cows that gained 20 kilograms or more. So let's see, 20 to 24, 25 to 29, and 30 to 34. That would be 20 kilograms or more. So how many would that be? That would be 16 plus 14 plus 2. Okay. 16 plus 14 plus 2, that's 30. Plus 2 is 32.32. Okay, that's the probability. So now we maybe have a, remember, if you're doing the mean, you could add in a column, the FX column. That might be the easiest way to do it. I'm just writing in the answers quickly now. If you could verify that for yourself, right? Add it up and I'll give you 1785. And then the 1785 divided by the 100 is going to give you the 17.85. And that's how you get the mean. Okay, so if you didn't finish it for homework, and then you could do this one as well for homework. Now, I have the answer here. It's not on graph paper, but I have the answer. I'll send it to you, but try it on graph paper. And then anything else, we have more, I'll send it to you as well, but these would be optional, okay? So if you feel like you need to really want to practice them and be really prepared, you could do them to practice, but at least do the question 2 for homework, right? So you have 1 histogram, 1 frequency polygon for homework, but certainly practice as many as you feel you need to, right, to get comfortable with it. Especially if you know you're not really doing a lot of these in class, in school, right? And you need to do the practice on your own, then do more, right? Do more if you need to practice, because you need to be able to do them quickly without thinking too much, right? A little bit of muscle memory as well. All right, so next week we will correct the homework and we'll be moving on to cumulative frequency curves, right? And that'll be the end of statistics. All right, so I'll see you next week then.